welcome to the first Organic Chemistry 1 online lecture. Today we're going to talk about Iupac nomenclature. Here are the topics we're going to cover today. Iupac stands for the International Union of Pure and Applied Chemistry, and it's essentially the governing body that determines how molecules, atoms, any chemical substance is named, and it's meant to come up with a universal system. So in the context of organic chemistry, it's meant to define a nomenclature that's unambiguous, meaning that if there's a molecule that you can draw a specific name from it, or if there's a name that you could draw a specific molecule from that. So let's start with the simplest type of organic molecule. It's called the alkane. The alkane is any substance that only has carbon and hydrogen, but it's even more specific than that. It also has no pi bonds, so that means no double or triple bonds, only single bonds. And also, it has no lone pairs, free radicals, or formal charges. And what that basically means is that the only thing you can have is a carbon-carbon bond or a carbon-hydrogen bond. That is an alkane. So let's start with the simplest of alkanes there is. That's called methane. A methane essentially has a carbon, and then it has 4 hydrogens attached to that carbon. So the carbon has an octet because it has 8 shared electrons between each of the 4 bonds. And this methane has a chemical structure of CH4. Next example is propane. Propane has a chain of 3 carbons together, and then that is surrounded by hydrogens. Each carbon has 2 hydrogens plus 2 extra hydrogens at the end. So in total, the formula is C3H8. So if we wanted to come up with a general formula for any of these alkanes that I've showed you, they always take the form of CN, where N is the number of carbons in the chain, and then H2N, because each carbon holds 2 hydrogens, plus 2 for the 2 hydrogens that are at the end of the chain. So an alkane will always have a chemical formula in this form. So the simplest type of an alkane is a straight-chained alkane, like the 2 examples that we showed. A straight-chained alkane can be named using a prefix at the beginning of the name, and then it will end in ane, ane, just like methane and propane from the examples. So in this table, I'm showing the carbon chains from 1 to 10 carbons, and this will be the extent of what you have to memorize as far as naming alkanes. So there's some common ones that you've probably seen before, like butane or octane. Some of these roots come from Greek, and some of them just are like the Latin number roots, like hex and hept and oct. So they shouldn't be too hard to remember. So let's do an example. What is the chemical formula of octane? So what is the general chemical formula for an alkane that we talked about? It's CnH2n plus 2. And octane, as we showed in the last table, has 8 carbons, N equals 8. So therefore, the formula is C8H18. So the next simplest type of alkane that you can have is just taking a straight chain and connecting its ends to create a ring. These are called cycloalkanes, and essentially you name them the same way that you name a straight chain, except you add cyclo before the name. So let's just jump straight into an example because it's pretty straightforward. What is the chemical formula of cyclooctane? So octane we just went over in the last example. So cyclooctane is just a straight chain that's connected at the ends. So if you had to draw its line structure, it's just an octagon. And so each of those carbons is going to have 2 hydrogens attached to it. And now because you've connected the ends of the carbon chain, there's no longer those extra 2 hydrogens at each end. And so the formula for this guy is just C8H16, or in its general form, CnH2n. That's the general formula for a cycloalkane. Backbone, root slide, go. So let's try a different example. In this molecule that I'm showing here, and I'm not going to tell you how to name it, what is the longest carbon chain in the molecule? So it's a common error to just sort of look at the horizontal chain and assume that that's the longest chain. Because sometimes the way it's drawn, sometimes the longest chain might go down one of the branches. So in this case, for example, if you draw the line going horizontal but then go up this 2 carbon chain, that actually creates a longer chain than if you just went down the 1. So that is the longest carbon chain. And in this case, that is the backbone of this molecule. The backbone is the longest chain or ring that exists in a molecule. And the root is the main part of a compound's name, and that name is derived from the backbone. So for this molecule, what is the root? Meaning, find the backbone and then determine its name. So what is the longest chain or ring in this molecule? So if we look at the longest chain, it's 5 carbons long. If we look at the longest ring, it's 6 carbons long. This hexagon actually has more carbons than the chain. So therefore, the ring is the root. So the root of this molecule is cyclohexane.